So how to assign E and Z configuration to the geometrical isomers? So today we will discuss about the rules which tells about the assignment of E and Z configuration of geometrical isomers. So prior to moving towards E and Z isomers, we need to discuss something about cis and trans isomers. So what are cis and trans isomers? When look at the example A. In this case, there is double bond between carbon and carbon. When each carbon is attached to a hydrogen and a non-hydrogen substituent, then these geometrical isomers can be identified as either cis or trans. In the first case, the methyl groups are present on the opposite sides of the plane. So this will be designated as trans isomers, as in this both the hydrogens are also present on the opposite sides. If we look at the molecule B, in molecule B, both the methyl groups are present on the same side of the double bond, and as well hydrogens are also present on the same side of the double bond, then it will be named as cis isomer. And similarly, there is a case for the molecules C and D. In molecule C, the hydrogens are present on the opposite side. And in case of D, hydrogens are present on the same side. Then when the molecules are present on the opposite side, then it is trans. When it is on the same side, then it will be known as cis. Then the molecule C is trans isomer and molecule D is your cis isomer. So there are some limitations of the concept of the cis and trans isomers. It is limited to some molecules. So where it is limited to some molecules, where the molecule have more than 3 non-hydrogen substituent. So jumping to example E, in this case, the carbon-carbon double bond is present and the carbon number 1, it is attached to 2 different groups, and carbon number 2, it is also attached to 2 different groups. So there are no groups which are similar in nature. The cis-trans configuration is assigned on the basis of the same groups, whether these are present on the same side or the opposite side. But in this case, the concept of cis and trans isomer is very ineffective. So for molecule E, there is some another concept that is of E and Z configuration. So what is E and Z? E and Z configuration is basically assigned to those molecules in which there are more than 3 different non-hydrogen groups or substituents. So let me discuss about the E configuration. E means antigen. It is a German word. It means opposite. Opposite means when the high priority groups are present on the opposite side of the double bond. This is your carbon number 1, carbon number 2. So carbon number 1 is on the left side. So you have to rank the molecules or groups on the basis of their priorities. If the high priority groups are opposite side, then it will be designated as E configuration. Here, so I will discuss the example of this one on later, but first is to clear the difference between the E and Z isomers. Z means jism, and this is also German word. It means together. When the high priority groups are present on the same side of the double bond, then you will designate it as Z isomer. Yeah. So basically, this is the difference between E and Z configuration. So moving to examples, so that and what are the rules for the E and Z configuration to assign their nomenclature? First one is you have to determine 2 substituents on each double bond carbon separately. You have to remember one thing, it should be separately. Such as example, In this example, this is your carbon number 1 and carbon number 2. On the left side, carbon number 1. Carbon number 1 is attached to two substituents. One of them is bromine and another one is methyl group. Clear? And you have to rank these molecules on the basis of atomic number. The group which have higher atomic number will given the more priority as to the substance which have lower atomic number. So among these, as bromine has the atomic number 79 and the carbon has atomic number 6, so that's why the bromine is given more priority as compared to methyl group. So methyl group is prioritized as high priority group over in this molecule. So this is your one, sorry, I will designate one, and methyl is your second group. And now, similarly, we have to find out the higher priority group on the carbon number 2. So carbon number 2, it is further linked to carbon. And here on this side, it is also further linked to the carbon. Yeah. And the carbon here is present is linked to the triple bond. When there is triple bond, it is considered as triple C. It means there are three carbons are present over here. So this is your rule. ICP rule, that is called Kahan-Ingold Prelog rules. These people have made some rules to designate E and Z configuration. Okay, so on both sides, the first atom is your carbon. Here is carbon and here is carbon. Now look at the second one. So second is here is triple bond. So it is designated as triple C. And here the second atom is oxygen. So out of oxygen and carbon, which have higher molecular weight, oxygen has atomic number 8 and the carbon have atomic number 6. So oxygen is given the more priority as compared to the carbon. So in this molecule, the right hand side of the molecule, so this group is given more priority as compared to the alkyne one, in which there is triple bond. So it's your first priority group and that is second priority group. So look at this molecule, both the priority groups are present on the opposite side. So that's why it is designated as E isomer. Clear? So the ranking is based on the atoms, substitution, or groups which have higher atomic number. So look at the another example. In this case, this is your carbon number 1 and carbon number 2. Bifurcate it into two parts. This is your left side. Okay, carbon number 1. Again, bromine and methyl groups are present here. So bromine is given more priority as compared to methyl group because it has high atomic number. This is your 1 and this is your second priority. Now, moving to right hand side. Right hand side, this carbon is attached to hydrogen and hydroxy group. Hydroxy group contain oxygen. So oxygen is given more priority as compared to hydrogen. Again, this is your first priority group and this is your second priority group. Clear? The high priority groups are present on the opposite side. So that's why it is also named as E isomer. Clear? So this is the concept to designate E and Z isomer. So look at the more examples so that we can clarify the more rules. Always remember one thing more: if the first atom on the both substituents are identical, like as in first case, there is the first atom was the carbon, then proceed along both substituents chains until the first point of difference is determined. So the molecule F, just a second. In molecule F, this is your carbon number 1 and carbon number 2, and bifurcate into the two parts. The carbon number 1, the carbon number 1 is linked to hydrogen and the carbon group. Of course, the carbon has high atomic number as compared to hydrogen, so it is given first priority and the hydrogen will given the second priority. And on the right hand side, the carbon is attached to this propyl chain and this ethyl chain. So the first atom on both sides is carbon, carbon, and two hydrogens. Here, okay, then it is again linked to carbon. Again, it is linked to carbon. Okay, so there is a difference in the carbon B. The carbon B, it is attached to two hydrogens in the propyl chain and one methyl group. In this, the carbon B is attached to three hydrogens. Here, this has more weightage because this carbon is further linked to the carbon atom, as carbon have more molecular weight than the hydrogen. Here, so here I just want to tell you we have to proceed until the first point of difference is determined. A and A both are same, but the difference is in the B carbon. B carbon is linked to one more methyl in propyl chain, and in this, the B carbon is linked to hydrogen. So this group is given more priority. Clear? So this is your first priority, and this is your second priority. So in this case also, both the priority groups are present on the opposite side, and it is also named as E isomer. Clear? Okay. Then the molecule G and H. In molecule G, goes bifurcate in the center. So out of carbon number 1, carbon number 2. Carbon number 1 is attached to two substituents. One of them is chlorine and another one is fluorine. Chlorine has more higher ranking as compared to fluorine because its atomic number is 35.5 and its is 9. Sorry, its atomic number is 17. 35.5 is its molecular weight. Here. So you just rub this. So chlorine is given high priority. And then on the right hand side, the second carbon is attached to iodine and bromine. So among iodine and bromine, iodine has more priority as compared to bromine. Yeah. So this is your first priority. This is second priority on left hand side. And on right hand side, iodine is given first priority and bromine is given second priority. Now, the both priority groups are high ranking priority groups are present on the same side, then it will be designated as Z isomer. Clear? So moving to example H, in these molecules, there is different arrangement of these halogens around these two carbon atoms or around the double bond. If we look at the carbon atom number 1, again, chlorine is more priority, has high ranking as compared to fluorine. So fluorine is given true second number and chlorine is given as first number. And if we look at the carbon number 2, again, iodine has high priority as compared to bromine. In this high priority, ranking groups are present on the opposite side. So it is named as E isomer. So I think it is more clear from these examples how we can follow the rules for E and Z isomers here. So there are certain another example like molecule I and J. So this is the example of butene. Clear? In butene, the two same groups are present on the same side in I molecule. So it can be also designated as cis molecule. Clear? And the J molecule in this the methyl groups are present on the opposite side and hydrogen as well on opposite side, then it is known as trans molecule. But these isomers can also be designated as E and Z on the basis of high priority ranking. This is your carbon number 1 and carbon number 2. If carbon number 1, this is your high ranking group 1 and this is your second. And same on the right hand side, methyl group has more priority as compared to hydrogen. So both the groups are present on the same side, high priority groups. So it will also be designated as Z isomer or Z isomer. But in case of this molecule, the high priority groups are present on the opposite side. So that's why it can be also designated as E isomer. So in these molecules, we can give nomenclature according to cis and trans rule as well through the EZ configuration. Clear? So it is not necessary that Z isomer always will be cis isomer or E will be trans isomer. It will be more clear from some other examples also. Clear? So example number K. In this, if you look at these two methyl groups are present on the same side, then we will name it as cis isomer. Clear? But if we look at the EZ isomers, clear? This is your carbon number 1 and carbon number 2. Carbon number 1 is attached to methyl group and hydrogen. Methyl group has given more priority as compared to the hydrogen. So on the right hand side, there are two group also, methyl and bromine. Bromine is given more priority as compared to methyl group. So this is your priority number 1 and this is your second priority. In these high priority groups are present on the opposite side of the double bond. Yeah. So it will be designated as your E isomers. E isomer is that in which the high ranking groups are present on the opposite side of the double bond. So it is not necessary that always E is trans or cis. So it may be any possibility. E and Z may be cis or trans. It depends upon the arrangement of the more substituent around the double bond. So just always remember the simple rules for E, what are for E and what are for Z, and as well for cis and trans. So upon the basis of rules, you can either name it as cis, trans, E or Z. So yeah. Look at the example L and M. In example L, this is your first carbon, second carbon, third, fourth, fifth. Clear? The carbon number 1 and the carbon number 4 both are geometrical isomers because these are attached to different substituents. Clear? The carbon number 1 here is your hydrogen atom. Just a sec. I need to remove this for the clarification. Here is your hydrogen atom. Here. Okay. So the carbon number 1, in this case, the high priority group is chlorine, as hydrogen has atomic number 1. Okay. So carbon number 2, here is your hydrogen atom, and 1 it is linked to the carbon chain. And out of carbon and hydrogen, carbon has given more priority as compared to hydrogen. So this is your 1 and this is your 2. So high priority groups are present on the opposite sides. So that's why your carbon number 1 is E isomer. If we discuss about the geometrical isomer configuration of carbon number 4, carbon number 4. Hmm. Carbon number 4. So of course, out of carbon and hydrogen, carbon is given more priority. So the lower one group is given more high ranking as compared to hydrogen. And the carbon number 5, it is attached to methyl group and chlorine. Among chlorine and methyl group, chlorine is given to the highest priority because it has high atomic number. So this is your 1 and it is ranked as 2. So in this case, both the high priority groups are present on the same side. So your carbon number 4 is given Z configuration. So what will be the name of the molecule? Its name is 1E4Z. Here, and there are chlorine groups are present at the first carbon and the fifth carbon. So that's why 1,5 dichloro 1,4 hexadiene, as it contains 6 carbon, 1, 2, 3, 4, 5, and 6. So 6 carbon for hexa, its word root, and 2 double bonds are present, that is for diene, and these are present at first and fourth position. First is E configuration and fourth is your Z configuration. So then the molecule contains the multiple bonds, and you have to check whether it is geometrical isomer or not by looking at the number of substituent, and if these are hydrogen atoms or non-hydrogen substituent, and then assign the nomenclature according to their high priority ranking groups. Here, and look at the example M. So I will draw here this molecule. Okay. So first of all, just number these atoms. 1, 2, 3, 4, 5. Yeah. Okay. So there is double bond present between carbon number 2 and 3. The carbon number 2 have different substituent. One is methyl group and another one is hydrogen. Carbon number 3. One of them is ethyl group and one of them is allyl group. Here. Okay. So carbon number 2. Methyl group will be given to the more priority as compared to hydrogen. This is your first group and this is your second group. Here, and the carbon number 3. In carbon number 3, there is one carbon. Just label it as A. And carbon number 4, this is your one carbon, label it as A. Okay? Now, both are the carbon atoms. So there is no difference between the carbon number A on the both sides, on the both chains. But the carbon number 4, it is further linked to carbon and having double bond. So there is the double bond between carbon and carbon. So it will be considered as 2 carbon. But this is the single carbon, and the single carbon, it is given low priority as compared to this group. So this group is given high priority. Here. So in this, the high priority groups are present on the same side. That's why it will be designated as Z configuration. So carbon number 2 is designated with Z configuration. Clear? There is also a double bond between carbon number 4 and 5. So if you look more clearly at carbon number 4 and 5. Yeah. But the bond between carbon number 4 and 5, this is not a geometrical isomer because there are 2 hydrogen atoms. Here is also a hydrogen atom. So it cannot be assigned as cis trans or EZ configuration because this is not your geometrical isomer. So only carbon number 2 will be assigned as Z configuration. Yeah. So its name is Z 1 chloro, 2 ethyl, 1 3 butadiene. Chlorine is, so sorry, here is chlorine group. Here. So chlorine group is present over here. So this will be named as 1 chloro, 2 ethyl, 1 3 butadiene. 1. So its numbering will also be get changed if there is the chlorine instead of the methyl group. 1 2 3 and 4. Yeah. Okay, you can just similarly, if there is methyl group also, if we again consider here methyl group, then and this here is your methyl group 1 2 3. So same I will using the same last molecules if there is the methyl group. Okay, so this is your second carbon, it will be designated as Z configuration here. Yeah. So we need to assign the configuration of the following molecules. So this is your homework here. How you will assign the EZ configuration to these molecules based on the ICP rules. If you have any query, then let me know in the comment section and I will answer to your questions. Thank you.